Okay, we've got some very awkward little sequences here. I'm looking at question 12 with a dirty great yellow asterisk by them, so they're quite tricky. Let's move the camera a bit, I think. Alright, we've got 12A on page 19. Well, this is quite nice, actually. There's the first term. There's the second term. There's the third term. I think you can guess the next one's going to be 4 times 5 anyway. Now look. First term, second term, third term, fourth term. Now look at it. It's treated differently. 1 and 1, 2 and 2, 3 and 3, 4 and 4, n and n. Okay? So I reckon the sequence is going to start n, because whatever we have here as the term, it's expressed in its answer below it. Now, the next number, have you noticed, is one more than the term. So 2 is one more than 1, 3 is one more than 2, 4 is one more than 3, 5 is one more than 4. Well, how do you express that? That's called n plus 1. So that's the n plus 1, that's the n plus 1, because it's one more, that's the n plus 1. And what are these two doing? They're actually multiplying. If they're multiplying, I'll simply have to multiply n by n plus 1, and that is my nth term. If I want to multiply out, I can do so, but I don't need to do that. That's good enough. N times n is n squared, n times 1 is just n. So that is the sequence, the nth term of the sequence, and that's that one. It's clearly quadratic, plus an extra little bit on the edge. Right, let's see if it's actually true. Let's take 4 and shove it inside there. So I've got 4 multiplied by 4 plus 1. Well, that becomes 5. 4 fives is 20. Okay, let's just get rid of that little bit there. It can come out well. So 4 fives is 20. Well, there it is. 4 fives is 20. It's true. Absolutely works. Here's the next one. I work down here. I work in yellow. I've got here 2/3 followed by 3/4 followed by 4/5. Guess the next one? 5/6. Yes, it is. Now look, that's the first term, the second term, the third term, the fourth term, the nth term, sort of way up there somewhere, right across the river. There it goes, it's all gone. Okay, now look. 1, 2, 2, 3, 3, 4, 4, 5, n. What goes here? Well, if you look at all these numerators, they're one more than their original term. So for example, so their original position. So position 1 is a 2, position 2 is a 3, position n is going to be n plus 1. Okay, so each one of these numbers is one more than its position. And the numbers underneath is 2 more than its position. Alright, so for example, 4 up to 6, 3 up to 5, 2 up to 4, 1 up to 3, just add 2. So you take the n and then you add 2. And that is a beautiful nth term sequence. There it is. That's lovely, isn't it? So if I wanted to work out the 20th term, I'll just go 20 plus 1 divided by 20 plus 2, 21 over 22. That's very powerful. Let's do another one. These scary ones. I'm still working on question 12, and look at this one here. Absolutely horrific. That's the first term alone. Here's the next one. 2 times 3 times 6. Here's the next one. 3 times 4 times 7. And the last one is 4 times 5 times 8. Well, that's the first term, highlighted in blue. That's the second term. That's the third term. That's the fourth term. I think you can see that the 1 and the 1 matches. So the 1 as part of the first term matches its number 1 position. The 2 as part of the second term matches its second position. So straight away I'm going to link these together and say, well, I've definitely got an n somewhere. So that works, doesn't it, each time? And the number next along is 1 more than the number before. So 2 is 1 more than 1, 3 is 1 more than 2, 4 is 1 more than 3. So I'm basically multiplying by n plus 1 afterwards. Is that okay? So the n is this position here. The 3 is 1 more than the 2. The 4 is 1 more than the 3, etc. Hence n plus 1. Alright? Now, last bit. How does 5 relate to the 1? It's plus 4 more, isn't it? How does 2 relate to the 6? It's plus 4 more. How does the 3 relate to the 7? It's plus 4 more. So I reckon to get this part of the term at the end, you take your number and then you just add 4. So 3 plus 4 makes 7. Yep. This number here, n plus 4. Well, 4 plus 4 does make 8. Absolutely works. So these are the 3 parts to my nth term. N, the original number, n plus 1, the next number along, and n plus 4, the last number. Okay, so what do? I've got to multiply these 3 parts. Okay, it says so. Put brackets, and there's your nth term. N, open bracket, n plus 1, close bracket, then open bracket multiplied by n plus 4, close bracket. Don't even try multiplying it out. Leave it as it is, and that is the nth term. And that claims to be, I don't know, it's beyond grade C, but they're not called it B or A or anything like that. So I'm going to leave that alone. Alright? One more. Here's one that looks dangerous. It's not, you know, dead easy. 0.1, 0.2, 0.3, 0.4, etc. So this is question 12D. First term, second term, third term, fourth term. I can see how 1 relates to 0.1. I can see how 2 relates to 0.2. I can see how 3 relates to 0.3, etc. So basically, if I take my n, here are all the n's here, I take my number and then I simply divide by 10. 4 divided by 10 is 0.4, 3 divided by 10 is 0.3, so my nth term is found by taking my number, dividing by 10, or you can say, if you want to, 0.1n, 0.1 times n. Easy, isn't it? Next one, let's make it fit here. Let's do 12E, probably the toughest one. 0.11, 0.12, oops, wrong, just copied it. 0.22, 0.22, 0.33, 0.44, okay. So we've got the first, the second, the third, the fourth. Now, I know that 1 times 11 makes 11, 2 times 11 makes 22, so there's an 11 involved somewhere, isn't there? So I reckon, let's take a look. Yeah, I've got it. So if I take my n value and multiply by 0.11, I should get that. So what is 2 times 0.11? 0.22. What is 3 times 0.11? Well, that's 0.33. I'm just using the fact that, you know, 3 times 11 is 33, 4 times 11 is 44, 1 times 11 is 11. So I'm just using that and just playing with the decimal points. And the nth term is simply 0.11 times n. And that claims to be the hardest one on that page.